could see right away 2 holes. See that? You see that? Come on, don't be shy. So there's a front cuvette holder and a back cuvette holder. In fact, we've got boxes of cuvettes here, all kinds of them. So you're putting some of this stuff in it. There's instead of 4 cuvettes, you've got 1 in the front, 1 in the back. Okay, so that's the cuvette holders. This is such an old computer system that anybody want to see the operating system? It's a tape disc. So this is an old instrument. Now, I'm not going to turn it on today. Every time you turn on the lamps, UV visible experts, how many hours do I use up on the lamp? 8. So these lamps that we have back here, particularly the deuterium lamp, every time you turn it on, in the first few seconds of operation, you basically subtract off 8 hours of lifespan. You typically have 2,000 to 3,000 hours of life, then you got to replace them. It costs $1,000. Yeah, $1,000 for the deuterium lamp. The other light bulb, not so bad, that's 50, but we're trying to protect the deuterium lamp. It's making that UV signal hard, and even hard to get it started. Okay, so now I'm going to pop the lid. Okay, so this is where it's really hard for you guys to see, and I apologize. They're giving you too many screens. Okay, we're going to start with where the sources are. So this is something you guys should be able to do a little bit. Okay, one of the things you're going to be faced with in a little bit is I'm going to stand you in front of this instrument. You're going to walk me through the path. Okay? And I'm going to point a finger to what is this? What is this? What does that do? And so that's why I'm doing this right now. The sources are over here. See them over here? There's 2 little glass bulbs. There's the light bulb. That's the tungsten halogen lamp. This big thing is the deuterium lamp. Okay? That's $1,000 bit of optical material there. The first thing that happens is you start the lamp. You should see this glow white and this glow purple. If you don't see one or the other, the instrument goes, it doesn't start. So you might have to do this a few times. To start it up on the back, the instrument switch, very hard to find. There's a little toggle switch back there, Victoria. Can you see it? So you have to reach back or reach over and turn it on. When you turn it on, you'll see this thing waiting and waiting and waiting. You'll see starting up or initializing. You want to wait until you see both lights. Now, you're not supposed to look at the light, but I always do. And so, okay, so the first order of business is get the light to go on. And then you've got to put it through this little system here because they're trying to make the light good. So there's a series of color filters here that rotate into place depending on whether you've asked for UV or visible light. The best way I can explain this is that the light that you're getting in there comes in all kinds of colors, and some of the colors produce a doubling of the signal that you don't want. And so they're trying to, it's like you have a piece of bread, and you don't want the outer part of the bread, the crust, so you cut away the crust with the optical filter. So you get just the good parts. So that's what these filters are doing. We haven't actually entered into the beam path of the instrument yet. That's all inside this box, which usually lies under this black mantle. Okay? So I've taken this off so you can see it. You can operate this thing as long as it's like this. You don't have to screw it all in place. But I'm going to take it off now just so that you can see the pieces. Okay? From the very, very beginning, we have a little thing in here called the slit control. See how this goes up and down? So the instrument can be set to different size slits. So how much light do you want? Well, you say, I want a slit of 0.25 or a slit of 0.5. This little doohickey here moves around and causes it to go like this. It also does this a little bit. So again, we cut the edges of the wrong light off the bread. Now when we go in, we made a little perfect little slit, a little hole. The light's coming in a nice little signal that's nice, straight, and of the right width. It's called the slit adjustment, or slit adjustment. So now we're into the actual beam path of the instrument, of the Zerny-Turner design. And the first thing you notice is, if you look here, you can see the monochrometer is considerably bigger than the one we had before. So I want you all to come look at the monochrometer's diffraction rating. It's right under here. And it's tied to a rather fancy-looking mechanical device. Can you see it back there? Come over here. Everybody, I want you to see the monochrometer. Is this thing right there? So, everybody, make sure you see the monochrometer. This is not okay. Come on, don't be afraid. Come on, Hallie. Get up here. Point to the monochrometer. You're going to be asked. Okay, the light came in through here. It came through the screw adjuster. What it's tied to, notice that the mirror is tied to a mechanical system that rotates. You can see that because there's a worm drive here. This thing does this motion according to whatever you program the instrument to do. And it slowly pushes the mirror forward and back. Okay? This is the same thing you were doing by hand when you're rotating the big knob. Well, this is doing it with electronic control. So this worm drive is driving the monochrometer serially forward and backward through the entire range of the wavelet, tipping the monochrometer just like before. Only you're not doing it, the instrument's doing it. Okay, by the way, is this a machine or an instrument? Instrument. Every time you say machine, I turn all red. I get mad. Don't do that. Machine is a backhoe. It digs up dirt. This measures. Okay, got it? Okay, so now that I've got this stuff monochromated, I have to get the light that I've got to go through the chopper. This is a little harder to see. The light that's monochromated ends up going either here or here. So there's a bunch of mirrors. It's really hard to see this. But after it's monochromated, there's a mirror here and a mirror here. Those are the two mirrors I'm using for the reference side and the sample side. This is the sample side, and this is the reference side. And so the thing that causes it to go left, right, from sample to reference is this little thing here. See, it's a wheel. And if you notice, the wheel has on one side a mirror, and on the other side, not a mirror. Okay, so one side of the mirror is saying I'm going to go something like this way. When it comes through, it goes this way. Now, this is a slightly different design than the little crossed one that we had before. Half of the mirror, half of the wheel is mirror, half of the other mirror is not. So it doesn't really matter. So they chose this design. But the idea now is that it's chopping the light left, right, according to the speed with which the thing is going. It goes about 100 RPMs. So it's going back and forth 100 times per minute. It's going back and forth. And so it's sending light here and here. This is called the chopper motor. This is called the chopper.
Chop what?
The chopper.
What's the other thing?
The chopper motor. It just drives just the motor. Okay, now once you've got a chop, I'm going to open this up. The light's going through here or through here, and under here is the photomultiplier tube. Okay, this is actually protected, and I don't want to unscrew it. Too much light goes into the photomultiplier tube, you can burn it out. In fact, when you open this hatch up, it automatically shuts the photomultiplier eyes down. Basically closes its eyes. You don't want to burn it out. So all this ambient light, that's a lot of light. Because you're only seeing one wavelength. This is all the wavelengths. So this is like 100 times more light than it's used to seeing, and it makes it good light. So it's amazing. You can't screw it up. But once it's into the photomultiplier, and I'll explain how this works in a minute, guess what? The rest of this amplifies the signal. So here's the instrument, basically, and the rest of this is the amplification. Now, you have to be able to walk through this. And if I point and show you what's this, you have to tell me what it is and what it does. Okay? There's details associated with all of this. I'm going to have in a little bit of an explanation of how the two lamps work. You should be able to explain that. So this is where instrumentation starts for me. It's being able to walk